All right. So this is going to be a long heat wave, particularly across inland areas. So this is going to be an event that drags on for much longer than usual for heat waves at any time of year, particularly in July. And across some parts of the northern interior part of California may continue essentially through mid-July. There are some indications. So again, today is July 1st. That would be 10 plus days from now. So this is a pretty big deal event. Now, to be clear, this is not going to be the kind of heat wave that brings 105-degree temperatures to the beaches in San Francisco or LA. That's a different kind of heat wave, and that very likely will not happen with this one. So we're not talking about downtown San Francisco seeing an all-time record high or anything like that. It should be much warmer than average, and actually quite warm to even hot, even along the immediate coast for a few days. So it will be notably warm with an absence of a marine layer. But the real problem is going to be across inland areas. What do I mean by inland? Well, I'm being deliberately vague there, but the farther you go from the coast, once you're 20 miles inland or so, you're probably inland for the purposes of this heat wave. And your mileage may vary depending on the coastal topography, but generally speaking, what are the areas that are going to be hit the hardest? Probably everywhere from the lower deserts of Southern California all the way north and westward up through the high desert Antelope Valley, the San Joaquin Valley, the entirety of it, as well as the entirety of the Sacramento Valley, and also the foothills and the coastal mountains upringing the Sacramento Valley, and really in all directions, north, east, south, and west. Exceptional heat is likely to occur in all of these places, but what do I mean by exceptional here? I think that all of those previously mentioned regions have a high likelihood of seeing at least daily record high temperatures during this period, potentially on multiple days, in a few spots, perhaps even on as many as 5 or 6 different days, or even more. And then as well, the real challenge is not so much that we're likely to threaten all-time record high temperatures, although we might get close in a few spots. I said that was not super likely a couple days ago. The likelihood has crept up a little bit. Although, to be clear, all of those 125-degree temperature numbers you may have seen in your Apple Weather app last week are still ludicrously high and not going to happen in places like, say, Sacramento or Fresno. That's a very modest silver lining. See my previous commentary on why you should never rely on weather apps that only draw from individual deterministic members of single models. Nonetheless, this is going to be a severe, prolonged, potentially record-breaking heat wave that may have large impacts for much of California. So there are some places that could get close to their July monthly or really all-time records, because in many cases the July monthly record is the all-time record, because this is the time of the year when the hottest temperatures often occur. It's not the most likely outcome, but there's maybe a 10 to 20% chance that a few places could approach or even match their all-time records. But the more important thing, and the thing that I'm actually a lot more worried about than whether or not we meet that trivia, is the pure number of either cumulative or even consecutive 100 and then 110 plus degree days in large parts of the California deserts and the Central Valley. So again, the entire Central Valley will probably see at least one day above 110 degrees, and some parts of the Central Valley will see 5 to 7 days of 110 plus degree heat during this heat wave. Again, we're not talking Death Valley here. Death Valley will be up in the 120s for sure with this event. We're talking about much more heavily populated parts of the San Joaquin Valley, the Highway 99 corridor, the I-5 corridor, particularly in the far south, and then again in the far northern end of the valley. These are places where, yes, it's hot in summer, but it's not often hot like this, and certainly not for this duration. So where I think the most concerning records may be broken, first of all, are with respect to duration of temperatures in excess of either 100 or 110 degrees, depending on where you are. That's one challenge, because we may continue to see temperatures that hot beginning tomorrow in some places and continuing as late as Monday, Tuesday, or even Wednesday next week, without really much of a break. There may be a couple of quote-unquote cooler days in there, but those might just be days where temperatures drop to 108 or 109 instead of being above 110 in certain parts of the valley. So not really a meaningful break in the heat to speak of. And then the other problem, too, is that because this is a ridge that is actually, and I'm going to show you all of some map data coming up in a little bit, but because this is a heat wave with a ridge of high pressure centered offshore initially, so this is not a ridge that's expanding northwestward from the desert southwest, but this is actually one that's forming over the Pacific Ocean and then edging inland a bit. It will be pretty warm on the coast. That marine influence will be going away. And what's actually going to happen to an even more widespread extent than record daytime high temperatures are record warm overnight minimum temperatures. That's a bit of a tongue twister, but essentially it means the temperature at night never drops to a level below the warmest overnight temperature that's been observed on these calendar dates. And so what I'm expecting are widespread record warm minimum, so the record warm overnight temperatures all the way from the immediate coast throughout California. So, places even in coastal Southern California, coastal Bay Area, will probably be seeing record overnight minimum temperatures, even though those places might not see extreme daytime temperatures. So it's going to be notably warm, including at night. The big problem is going to be in the Central Valley, and in particular in the foothills ringing the Central Valley, places that could see temperatures of 100 to 110 plus for a very long duration. Overnight minimum temperatures might not drop below 70 degrees in many of these places, and in some parts of the foothills, not below 80 degrees. So we may actually see 150, 170 consecutive hours of temperatures above 80 to 85 degrees in the foothills during this event. It just isn't going to cool off even at night. And this is, of course, a problem for human health and physiology, because the human body often requires at least a certain number of hours of cool temperatures to maintain itself at a reasonably cool temperature in those overnight hours. Ideally, the natural world drops to that temperature overnight, or at least you have access, say, to some active cooling at night, so some air conditioning if the outside temperature doesn't drop to levels that are low enough. But if you don't get that reset, and some of these elevation bands, particularly in the thermal belt, between about 1,000 and 3,000 feet in elevation, so these are the foothills in California, really not going to see overnight temperature recoveries during this event. Those will be record warm. Also not going to see overnight relative humidity recovery, which is going to be important for what wildfires develop. And unfortunately, I'm not really using the term if wildfires develop, because I do think it's essentially inevitable during this event for reasons I'll go into in a minute. But wildfires will likely remain quite active at night during this event, because it will remain unusually warm, perhaps record warm, with overnight humidities that do not increase very much relative to how much they normally would, due to the extremely warm and dry air mass aloft, not just at the surface. So my two big concerns with this heat wave, although we will see daily record highs and a few spots may even approach monthly to all-time records, although that won't be the main story, my big concern is just that this is just going to go on and on and on, especially once you're more than 20 or 30 miles from the coast, for 7 to 10 plus even days in some places, and overnight temperatures will remain extremely warm. Historically warm in some cases. So we may actually end up breaking all-time records for consecutive or cumulative 110 degree days in parts of the Central Valley, and records for some of the warmest overnight minimum temperatures. Alright, so that's what the deal with the heat is. This is an event that's going to be probably most intense across central and northern California, away from the immediate coast, although now there are indications, especially as we go later in the event, that it will increasingly affect the interior portions of Southern California as well. So there may, although yes, it's always very hot in July in Palm Springs, but right now it looks like places like Palm Springs could also approach their all-time maximum record high temperature. I believe that's 123 degrees. Again, that is extreme heat no matter where you are. And so there are places all the way from the southeastern lower deserts of Southern California all the way north to the Mount Shasta area that could see record high temperatures during this very long duration, potentially very high impact heat event. Okay, so then that's the heat part. I'll come back to that in a minute with some charts. But the other piece here is the fire risk. And normally I would argue that the fire risk during heat waves in midsummer is often not as significant as the fire risk, say, during a strong wind event in the fall. Partly because often some of California's most dangerous fires are wind-driven, and we tend to see those offshore winds in fall. And also because the autumn is the period where you essentially have the maximum cumulative effect of vegetation drying heat waves from the whole summer leading up to it. So vegetation in most of California becomes progressively drier from May through September or October and reaches peak seasonal dryness sometime between between September and or maybe even October or November in a particularly dry year. We're in early July, vegetation has not reached whatever the peak seasonal dryness is going to be this year. We're not there yet. However, we are seeing that nonetheless that the level of dryness right now is rapidly changed in recent weeks. So I was talking about how May and June featured a lot of conditions that were favorable for prescribed burning because vegetation moistures were still near to even above average in many places. That is changing rapidly and will continue to change during this heat wave to the point where I don't think that's true anymore. In fact, it's no longer the case that vegetation remains relatively unexceptional. The vegetation moisture and flammability metrics are going to skyrocket in the coming days. So I'll show you some evidence that in fact in certain ecosystems in northern and central California, vegetation moisture levels and potential flammability, if there is a fire, will be near record high levels for the calendar date. Not for peak season, so we shouldn't be comparing early July values to September values, but nonetheless, for this early calendar date, we will have gone from above average moisture just a couple of months ago to not only below average moisture now, but near record-breaking low moisture in certain systems. So this is essentially consistent with the warnings, that I've been trying to offer so far this season, that we see a rapid transition towards a much more active fire season sometime between July and August. And given that June ended up being unexpectedly warm and windy in some places, we're sort of at the early end of that prediction window. So it's early July, and I think we're there. Conditions from here on out, especially at low to medium elevations in California, are likely to be above average fire activity. Still not quite seeing that at high elevations, but we may get there now, especially with this prolonged heat wave coming up later in July or August. So with this event, the main risk of fire, not the exclusive risk, but the primary concerns are at elevations under 4,000 feet. Now, that may be good news for the higher elevation ecosystems and settings in California, but it is not so great news for the vast majority of the population of California, most of whom live well below 4,000 feet in elevation. So there will be elevated fire risks statewide during this event, so it will be significantly higher than it has been everywhere, but the peak concern is actually in portions of Northern California. From in the Central Valley itself, the foothills ringing the Central Valley, up to about 3,000 or 4,000 feet, and then also some of the coastal mountains in particular in and near the San Francisco and Monterey Bay areas. These are where there are now red flag warnings in effect, because it's not only going to be very hot with plummeting vegetation moisture levels, but there are actually going to be fairly breezy to even locally windy conditions over the next few days. So it's a pretty bad combination, honestly, to have a potentially record-breaking heat wave that starts off with dry north winds veering offshore even, which is kind of unusual for July, but this is partly because, again, that ridge axis is uncharacteristically offshore to start out with this heat wave, very low humidity, breezes, and potentially record high temperatures. This is all coinciding with two other pieces that are important. One, as I've mentioned before, there is an unusually heavy herbaceous vegetation growth this year because it's been wet in most of California for 2 consecutive years and relatively mild. The good news is that allowed some of California's heavily vegetated ecosystems to recover somewhat from years of historic drought, but of course the challenge now is that all of that extra grass and brush growth is now very dry. Reaching record dryness levels, as I mentioned, would be a real concern later this year if we got record heat, as we have been seeing. And that is now fully dried out. So we have extra fuel for the fires at lower elevations, so more grass and lighter brush than there would normally be because of all that extra growth the past couple years. Now we're going to really kiln dry it this week. And as if that weren't enough, this is of course the week of the 4th of July holiday. And as I pointed out in my most recent Weather West blog post, you can check it out for a graphic from a recent paper publication that illustrates this. The single day of the year on which there are the most human-caused wildfire ignitions in the United States is, take a wild guess, the 4th of July. And the primary reason for this is fireworks. Not formal professional fireworks shows, which only very rarely spark fires. These are mainly fireworks that are lit off by private individuals, ones that are in most cases in fact illegal to possess or use in the locations in which they are used, and that is the main reason why there are so many wildfire ignitions on the 4th of July. Now in a typical year, a lot of those ignitions don't go anywhere. Fire departments of course are always on high alert. There's usually extra staffing on the 4th of July for precisely this reason. It's predictable human folly, and there are ways to mitigate the risk somewhat. But the problem this year is it's going to coincide with what are effectively red flag conditions to begin with. In the midst of a severe heat wave with a heavy grass crop this year, very high temperatures, low humidity, and potentially lingering breezy conditions. Along with whatever fires start in the next couple of days with these hot, dry, and breezy conditions, there will then be a spate probably of new ignitions from fireworks and from folks doing other stuff outdoors in these recreation areas, things that may be in many ways more innocuous than setting off illegal fireworks, but still can result in sparks accidentally that can lead to wildfires. So there is a high likelihood to believe that there will be an increased number of human ignitions this week in particular relative to a typical week, along with a potentially record-breaking heat wave. Red flag conditions, buckle up, I guess. I think California's fire season is likely to escalate considerably over the next 5 to 7 days. So there are red flag warnings in effect. As I mentioned, this will not be an extreme wind event. These are not going to be 60, 70 mile an hour winds, so that's the silver lining. Of course, winds of even wind gusts of 30 or 40 miles an hour, which we may see are unusual when they're offshore winds during a heat wave this time of year, which could still cause problems. And it sounds like PG&E is considering a fairly significant public safety power shutoff as a result across portions of Northern California. I'll take you to a map to show the general areas. I don't think this is going to affect millions of people. It looks like it's probably one that will affect more like tens of thousands of customers rather than hundreds of thousands or millions as we've seen in previous years. I'm a little bit surprised we're seeing them at all, simply because these do not appear to be very strong winds, and to my understanding, the main purpose of de-energizing lines is to prevent either the lines themselves from blowing down or debris blowing onto the lines during such events. 30 to 40 mile an hour gusts don't seem like they should necessarily trigger it. It's certainly going to be dry and hot, but that alone wouldn't usually trigger these conditions. So I think that there might just be a concern that even a single spark or two could be really problematic in this setting. So we'll see just how widespread those public safety power shutoffs are. But this could be a problem for some folks because it may occur during the peak of the heat wave when it is extremely hot with temperatures exceeding 110 degrees in some of the places that will receive the shutoffs. So your normal access to air conditioning might not be available. You might not even have access to fans. So this could be a real issue, yet another negative externality of these public safety power shutoffs. that we don't always have to deal with as much in autumn, when often those wind events at least aren't always super hot. But this is an event, one of the reasons why this heat wave is going to be so problematic and so intense is that it's occurring relatively close to the summer solstice. Of course, we're less than 2 weeks out from the longest days of the year. And so the sun angle is particularly intense, and it's a high angle on the sky, unlike when we get those autumn offshore wind events and those coastal heat waves during October, say. And the days are long. There's a lot of hours of insolation, insolation, not insolation. Insolation being a compound acronym, I guess, for incoming solar radiation, meaning that there is just a whole lot of hours during which energy input from the sun can accumulate near the surface of the Earth during a heat wave that occurs within a few weeks of the summer solstice. So this will feel different than a heat wave with offshore winds in, say, September or October, because the sun is higher in the sky, we have longer days, we're closer to the solstice. So this is going to be, I think, a challenging week ahead, and frankly, this may continue beyond this week. So this looks like a potential multi-week event. Just saying hello to everybody who has recently joined. There are a lot of folks. As is often the case, I notice that people really like to attend these sessions when there's something interesting going on in the short-term weather conditions in California. This, of course, being the heat wave and potentially severe fire weather event that is imminent beginning essentially tomorrow. Just recapping that I've given an overview up to the present after resolving some audio issues, and I'm about to launch into some map analysis, and we'll walk people through what's likely to happen next. But just wanted to emphasize one thing before I do so. Since I am both a meteorologist who studies the weather and a climate scientist who studies the longer term variations on larger scales in the Earth climate, we know at this point, it's almost a trivial statement to say, in fact, that essentially all heat waves have a detectable human fingerprint at this point. In a warming climate, heat waves become more frequent and more intense virtually everywhere on Earth. So extreme heat events like the one that California is about to experience have been made worse and more likely by climate change. It doesn't mean there wouldn't have been a heat wave without human-caused climate change. It doesn't mean even that certain heat waves wouldn't be extreme. But at a given level of intensity, it makes it far more likely to occur than it would have been otherwise, and it makes the overall occurrence of a heat wave during this window of time also more likely than it would have been. So is climate change the only thing at play? No, of course not. There have been heat waves since time immemorial, but there sure are a lot more heat waves and more intense heat waves today than there would have been had the Earth not warmed by, so far, about 1.4 degrees centigrade. And the global average, multiply that by about 50% to get how much it's warmed over land, because the land is warming about 50% faster than the oceans, and then multiply by 1.8 to get to Fahrenheit, and all of a sudden that's not such a small number anymore. All right, I'm going to go to the maps now. Or actually, I'm going to quick take questions first and then go to the maps, since just to clear out the comments up to the point. Joanna Warrens mentions from near Durham, near Chico, a farmer worried about the walnut crop. I think you may have reason to be concerned. I'm not exactly sure how temperature sensitive walnuts are, but you could well see quite a few days at or above 110, with very warm overnight temperatures in particular, maybe not getting below 70 degrees for over a week. So I suspect that is going to be a problem for some nut orchards, even if it's just a matter of keeping up the level of irrigation that you need to prevent damage to those tree tissues. All right. A comment that someone is planning on going to Death Valley on Saturday. What can I expect at Furnace Creek? Highest I've seen is 126. Well, you may see temperatures right around that range, 126. If you've been there before at that time of year, you know what you're going to be dealing with. But just to reiterate, a lot of people get seriously ill and die in Death Valley when they go during these really extreme summer heat waves. So if you do go, I would strongly recommend not leaving the paved road. That's where people tend to get in the most trouble. And carry a lot of extra water with you. If you do those two things, you'll probably be okay in the end, even if your car breaks down. But not a good weekend to go driving out on any of the the dirt roads leading off of the main highways in the national park there. So, do you want to go stand by the thermometer at the visitor center? That's one thing, but this is not a good weekend to go four-wheeling out there. In places where there are probably pockets, unmeasured pockets of Death Valley that'll get up to about 130 degrees Fahrenheit during this heat wave. That's just the way it is. I say that because in a future conversation, I would like to talk to my followers about how the very most extreme events on Earth we probably have never measured and don't know exactly what they look like. So all the records for hottest temperature on Earth, strongest wind speed, largest hailstone, whatever it is, are almost certainly undersampled, and there have been bigger events somewhere where we just have never had instrumentation in place to officially observe it. But that's a question for another day. If you go to somewhere hot, be really careful, bring a lot of water, and probably not the best time to go off on a remote corner of the park. A question from David, is this and any following heat wave this summer or fall still connected to the past El Nino or just a quote-unquote new normal? Well, as you'd expect, I already mentioned that essentially every heat wave has a human fingerprint, including this one. In general, the heat waves in the mid-latitudes are actually more likely in the transition seasons between El Nino and La Nina, so we are currently in that, and part of the reason why there's such a strong expectation that the west may be very hot this summer and into the fall is that does tend to be favored by those transitions between El Nino and La Nina. But then, of course, there is, on top of that, the global warming signal, which at this point is not a small factor. It's a major reason why there's such high confidence that the next couple of months are likely to continue to be unusually hot, and why we've already been very warm in recent months across much of the West, and record warm across really the planet at large. I'll come back to the fire weather question regarding feedbacks. That's an interesting one. We'll see if we have time for it today. Gracie asks, aren't a lot of the grasses we see drying out now the invasive non-native grasses? Well, a lot of the grasses you see in general in California and across a lot of the Great Basin are, unfortunately, a lot of them are invasive grasses. A lot of the California classically sort of famously golden hills in summer are in fact themselves invasive grasses in a lot of cases. So yes, those are the ones that tend to dry out soonest. The native grasses do have some increased resilience. They can remain growing in many cases later in the season because they often have deeper roots and have a better access to water deeper in the soil column. But those too are eventually going to dry out, and I think we will see that happen sooner rather than later. So it's a bit of a mixed bag, but in general, grasses are now becoming very dry at lower elevations, potentially even approaching record dryness levels in aggregate across the landscape right now, for the time of year at least. All right, a lot of folks mentioning that in their neighborhoods that there are lots of fireworks that are not officially condoned, that are presumably illegal. I remember that. I mean, anywhere I've ever lived in California, there have been just a cacophony of booms and bangs pretty much all night on the 4th of July, and that's true, all the way from, LA to San Francisco to the Central Valley, North Bay. I mean, so unfortunately, this is a very widespread thing. Hopefully some folks will at least be mindful that this is not an ordinary 4th of July in terms of fire risk. The risk is a lot higher this year than it would be in a typical year. The reality is, I'm guessing a lot of folks don't pay that much attention to this and perhaps don't care that much. If you're going to go light off fireworks, probably not checking the fire weather forecast to make sure it's reasonably safe to do so. So I think that the reality is there's going to be some firework ignitions. Hopefully we can mitigate some of them through messaging, but the reality is as well, there will be other sparks on the landscape this week too. So it'd be great to keep the firework ignitions to a minimum, but it's pretty hard to envision there not being quite a few fire starts, some of which will become significant and perhaps a couple of which could become quite problematic. Particularly because, of course, firework, fires, a lot of them start in close proximity to places where people live. Some people will go off and recklessly light them off in a national forest or something away from a town, but a lot of people are just going to the city parks or their backyards or some open spaces or something to light them off. And inherently these are close to where people live. So when you have a fire, it's already either right next to or in the wildland urban interface where it can cause problems for people very quickly. I'll talk about the energy release component a little bit. I'm going to bring up some charts for it. So just give me a minute here. Jack Lee, San Francisco Chronicle asks, with this heat wave, are there concerns about air quality this week? Curious if wildfire smoke or fireworks smoke could linger. I haven't thought about that as much, but yes, because as you point out, there are two potential sources for pollutant emission that is above average levels. One, any fires that develop will produce smoke, of course. Hard to predict exactly where and when, but there will be some. And then fireworks themselves produce actually much more toxic smoke than wildfires. Those will probably be concentrated on the 4th of July, and we know that all around the world, air quality can approach emergency toxicity levels in the wake of firework displays. And this is true both of professional displays, especially because those are usually larger and involve longer displays with larger fireworks with more compounds because you have more colors. Some of those colors are produced by pretty exotic compounds, a lot of which are metals, by the way. So that's what causes a lot of the vibrant colors in fireworks. So there's firework emissions both on large scale and on the local individual level. There's potential smoke emissions. And then there's the fact that under a strong ridge, you tend to have downward motion in the atmosphere. So you put a lid on the lower atmosphere, you trap pollutants in that stable layer. We aren't going to see fog or a sea breeze really on the 4th of July in most places this year. So we won't have the fog to sort of have those water molecules to sort of extinct some of the pollution and have it fall out of the atmosphere. We won't have that sea breeze to disperse the smoke as easily. So yes, actually there could be some significant air quality concerns, both because of increased emissions due to both fireworks and the likely wildfires this week, and then also the subsiding atmosphere putting a lid under this strong ridge, heat dome, if you will. I think it'll probably be appropriate to call it that. Together, that will probably result in some significant air quality problems. Worst in the Central Valley and in the Inland Empire, as I hate to say, as it often is in California, but locally elsewhere as well, either near the point source emissions from fires that develop, or even in cities with better air quality on average, but they have big firework displays. So all of that could be a problem this week. You may tell that I'm not the world's greatest fan of fireworks at this point. I think I used to be more, and then I realized just what the environmental implications of these kinds of displays are. Also, dog owners out there may have changed their tune as well. All right, let's see what else is there in the comments. And then again, I'm going to go to the maps. So I'm just trying to get some of these comments out of the way now. I'll go to maps and then come back to comments at the end of the hour. Potentially run a little bit long today is what I'm thinking. Question from Marky Keita, I believe. We'll see if I got your last name right. I'll see the comments later. Does the term heat dome have any meteorological validity, or is it just an eye-catching news term? I think it's reasonable to use. I mean, it's not a really formally defined meteorological term. What it means is a highly persistent ridge of high pressure in the middle atmosphere that becomes to at least a partial extent self-perpetuating as the temperatures inside the ridge, or the dome, if you will, progressively rise over time as more and more of that warmth evaporates soil moisture from the ground and allows more and more of the sun's energy to heat the air. So there is a self-reinforcing or vicious feedback, also known as a positive feedback, potentially baked into that, pun intended, I guess. So I do think there's sort of a reasonable, in fact, it may even make sense to formalize that scientifically as a large continental heat wave that becomes somewhat self-perpetuating after a while. I don't think anybody has formalized it in the literature to my knowledge. That's my understanding, that's my usage of it, and I think this event will at least somewhat qualify, especially if it drags into the second week, as it looks like it likely will. And you know, as you know, I'm you know I've coined a few colorful terms myself for phenomena in the atmosphere, and I don't think there's a problem with using language that makes the science accessible. I think it makes sense to use language that is still carefully selected and reflective of the underlying process at hand. So that's a somewhat subjective characterization, but I think heat dome checks enough of the boxes. It's intuitive, both colloquially, and it also evokes essentially the correct sense of what's going on. I don't have any issue with it. I think it's entirely appropriate from a news media usage perspective, and frankly, I'm starting to see it used in the scientific literature, although maybe it would be good to have a more formal definition of it, at least in that setting. All right, here. All right, I'm going to pop over to the map room, the virtual map room now. So you're going to see me. I will go away, and you're going to see full screen imagery for some maps and other data here. Slight tech error here. I just need to pull up the right tab in Chrome. Okay, here we go. All right, so that's going to pop back up. Got to get my screen drawing tool lined up, and then it should be momentarily on your screen here. All right, so first thing I want to show is this map from the European Ensemble. So this is the world's flagship, arguably the best weather model in the world. This is the ensemble average, so meaning across many iterations of the same model, perturbing the initial conditions a little bit, what do things look like? So I'm stepping forward in time. This is a map of normalized geopotential heights. So in other words, essentially the relative degree of anomalousness of the thickness of the half-mass layer of the atmosphere in units of standard deviation. That sounds really complicated. So what does it really mean? It means how unusually warm is the lower half of the atmosphere in different regions. The more red it is, the more anomalously warm it is, and again, that's in units of standard deviation. So I'm going to freeze it here in the early morning hours on the 4th of July. Obviously, there's a gigantic red blob over and even slightly stronger just west of California, where we're up in the 2 standard deviation territory. Given that we're in July, it says a lot that such a broad area is around 2 standard deviations above average for this time of year. Again, this isn't relative to the whole calendar year. This is relative in particular to the beginning of July, which is often when we see the highest heights in this region. This is a huge ridge. But watch what happens over the next few days. It weakens slightly, but actually expands to encompass much of northern and central California, as well as the entire Pacific coast. So it's going to get hot up into the Pacific Northwest now as well, with anomalously high heights all the way from South Texas up well into British Columbia along this ridge axis, but centered with this 597 decameter or greater ridge right smack over all of northern and most of central California. This ridge re-strengthens again as we go into the weekend. Look at that 2 standard deviation zone popping up again across far northern California and southern Oregon. This 597 contour is almost perfectly encircling California. So when I'm saying that, let me just bring up the screenwriting tool here. I'm talking about this region here. So that 597 contour, X marks the spot, essentially. during this event in California. And now I just need to, there we go. So stepping through, this is getting into next weekend. Slight weakening of the ridge, but it just remains anchored. This is essentially on Sunday. That 597 contour is still over California and Nevada with nearly 2 standard deviation of this ridge strength. So this is the peak of this heat wave will last essentially from tomorrow, Tuesday, all the way through Sunday. And then the following week, the ridge does likely weaken somewhat, but look at what happens. We don't really cool down to below average temperatures. We still continue to see this enhanced ridging, and then the signal by mid-July actually does show re-strengthening potentially over California and other parts of the West. Maybe some weakening more by early July. But if we look just at the most recent single member, not the ensemble now, but just the single run, the deterministic run from the European model, this is one of multiple plausible evolutions in the ensemble. This is showing an even stronger ridge going into the weekend than the ensemble average right now. So the operational run is showing something even greater, approaching 600 decameters over northwestern California this weekend, and then persisting a little bit longer into next week. So again, this is showing less weakening and then significant re-strengthening of the ridge next week. This only goes out through about 10 days. If we look at the most recent American model run, let's see what it looks like next week. This is playing out this week again with this ridging. Going into next week, again, showing pretty aggressive re-strengthening with a heat wave that then might start to peak across Southern California and Central California as we go towards mid-July. This would be a pretty bad scenario, essentially a 3-peaked heat wave. We're likely to definitely see at least 2 peaks, one on Tuesday and one maybe around Friday or Saturday. But this is suggesting there could be yet another peak going into the week after. Okay. So that's what this looks like from an atmospheric big picture. Just to reiterate, this is a map of, and I'm just going to pull up the geopotential height table. This is a map showing just how anomalous are these geopotential heights going to be. And if I pull this up for, say, Thursday, this map is going to show this ridge off the coast of California will essentially be, all the bright red areas are at historically unprecedented levels for this time of year. That's a big region. In fact, the big red region is almost the size of California. It's a little bit offshore, but it is something that shifts over the state a little bit more as we go later in the week. So if you go later, more of this anomalous ridge gets closer to the actual coast and expands over the west coast. So the short version of this piece is essentially just to say that a pretty large piece of this ridge will be at historically unprecedented levels for a portion of this event, particularly as it's offshore, and that could lead to record high temperatures over land. All right, so one other thing I want to show, now this comes down to the wildfire risk. Somebody earlier in the comments asked about what are ERCs. These are the energy release components. This is a composite wildfire risk variable. Essentially, it aggregates the moisture, or the dryness really, of various fuel types. So this is saying that you're looking across different types of vegetation. So of course, grass dries out much earlier in the season and faster than, say, a giant log on the forest floor. And also live vegetation, so anything that's green, dries out more slowly than anything that's dead, whether that's a brown grass or a dead tree or a log on the forest floor, or sticks and tree litter, leaves on the ground. Those all dry at different rates. This takes into account essentially the composite of all of those drying rates as driven by recent and predicted future weather conditions. So when you see the blue curve here, this is what the energy release value was in a particular part of Northern California so far up to the present. The little green extension on the blue line is the predicted values of the energy release component for the same area based on weather conditions over the next few days. The red values are the highest recorded values in the last 20 years or so, again keeping in mind, or in the last 10 to 15 years, excuse me, keeping in mind that the historically highest values in most places have occurred in the last 20 years. So if we take a tour of different parts of Northern California, the energy release component along the north coast, and you can see this, I'm going to bring back my drawing tool, is going to be approaching or even exceeding potentially record values for the calendar date for the period of record. Again, not an extremely long period of record here, but it is also a period over which, generally speaking, the most extreme wildfire burning conditions of the past century actually occurred. So it's saying actually quite a lot. So I scroll down, again, we see something similar for sort of the interior Mendocino. So again, we're not actually talking about the immediate coastal strip here. Most of this is being driven by the interior part of Mendocino County and adjacent counties. But again, we're seeing a prediction that these values this week could approach or exceed the recent historical maxima for this time of year. And frankly, that's not that far from the historic maximum at any time of year. So these are pretty striking values, I would say, right now. We look at a few other places. The Bay Marine, this is sort of the immediate San Francisco Bay Area, the more marine-influenced environment. Here, a clear upward trend in fuel dryness, but also not necessarily reaching record values, at least earlier in this heat wave, reflective of the fact that it was a relatively wet winter in this setting, and we're still not going to see the peak of the heat wave in this part of Northern California. Nonetheless, these are the average values for this time of year, and we are up here. So we're definitely well drier than average. That still speaks to higher than average Bay Area fire risk at lower elevations. And then if we look at the Diablo and Santa Cruz Mountains values, these are sort of a higher elevation and more inland areas that have dried out earlier. They're often above the influence of the marine layer. Here again, we're seeing values that are at or above even the recent historic maximums for this time of year in terms of vegetation flammability, which is really, if you have to, a two-word summary of what is the energy release component telling you, it tells you about vegetation flammability. The higher the value, the more flammable it is. So again, we're getting close to what the typical peak seasonal values would be, or even exceeding that in these settings. Similar story up in the northwestern mountains of California, the Sacramento Valley foothills, which is where the red flag warnings are in effect. This is a little bit less true in northeastern California, although even here we're above the historic average for the date. Northern Sierra, again, looking very high, although I think this is likely being driven by the lower elevation portions of the domain, so we're not really talking about up at 6,000 or 7,000 plus feet. It's still pretty damp up there. You get the picture. And this is being driven, if you look at a similar map for the 100-hour fuel moisture, this is essentially for heavier brush or debris on the forest floor, for example. So not really talking about logs in the forest floor, also not talking about dry grass, but we're talking about that intermediate woody debris. These values are really kind of striking. Along the north coast, this is suggesting that this week, these values may approach historic minima for any time of year for this type of vegetation during this extreme and prolonged heat wave. Similar story for mid-coast Mendocino type realm. These are, I almost wonder if the model prediction is sort of over-predicting it, because that is an incredibly low dry value. Again, not seeing as extreme values in the Bay Marine environment as you'd expect, but again, getting really low up in the Santa Cruz Mountains, Diablo setting, and again, also approaching historic minimum in the Sacramento Valley and surrounding foothills. So really what I want to point out, I was reluctant to talk about vegetation being super unusually dry up to the present, because it really wasn't, and you can see that, by the way, reflected in this. It was in some cases somewhat drier than average recently, but definitely not at record values, which would be down here. But that is now going to change as we're in this window. This is going to be a different fire regime than we've seen so far this year, for sure. All right, and then finally, I promised folks I'd show them the PG&E potential outage map, which is not that easy to find. If you're trying to find it, take a look at the URL up here. This is, again, not likely to affect that many people. These are fairly rural areas, although, of course, people still do live there. I'll do a quick tour. This is part of, I think, Yolo, maybe eastern Napa County, west of Winters. There's a swath over here where there could be some outages. Some fairly remote parts of southern Lake County, and then little pockets of Sonoma County, Napa County. Again, that's Yolo County. As we get up towards Colusa and Glenn counties, this is where there might be more outages, particularly on the west side. Again, no big towns or cities out here, but a fair number of people who live out there. West side of the valley into the foothills looks like where PG&E is planning a lot of outages. Also, in the uplands of Butte County above Paradise and above Lake Oroville, there could be some outages. And then again, along the west side of the Sacramento Valley, going all the way up into the foothills, sort of surrounding Redding and Shasta area. Here, there probably will be more people affected. This will also affect a lot of the recreational areas outside of Redding and Red Bluff, which a lot of folks may be headed to in the next couple of days because of the holidays. So just zooming out, these are the orange areas. Again, most of the Bay Area not included. Most of the west side, the east side, foothills not included, except for a patch around up above Paradise. But the main region in question here is the west side of the Sacramento Valley and the foothills, along with the portion of the just east of the I-5 corridor near Redding and Shasta. All right, so I'm going to turn off the screen sharing again. You're going to see my face again momentarily. There we go. And going to potentially address some more questions. So we'll see how many there have been. In the meantime, okay, not too many new questions, actually. Let's see here. Question about hydroclimate whiplash. I'm going to save that, table it for a little while. I need to finish our review paper, our resubmission of our review paper on global hydroclimate whiplash in a warming climate by Friday of this week. So that's how I'm going to be spending the 4th of July holiday, unless I need to do an emergency YouTube session because things have really gone sideways, which is possible, by the way. I may do another live session later this week as conditions warrant. We'll just have to see what happens. Could be fire or heat related. So stay tuned for that. That might be on relatively short notice. But let's talk about hydroclimate whiplash a little bit down the line. I'll have a lot more to say about it then. All right, so not too many additional questions. I'll keep looking if they come in the next few minutes. And again, today's topic is related directly to the heat wave and fire weather event coming up, so I'm going to be trying to keep it to that. Again, just to reiterate for folks who joined later, because there are quite a few people viewing right now, and the numbers are a lot higher than they were in the beginning, so count yourself lucky you missed the audio issues up front. This is going to be a long-duration heat wave in much of interior California. I'm still expecting to see record temperatures, at least daily records, and perhaps some places that will get close to monthly or all-time records, probably not exceeding them, but maybe getting within a few degrees, all the way from Palm Springs in the lower deserts northwestward, all the way through the high desert, the portions of the Antelope Valley, the San Joaquin Valley, the Sacramento Valley, the foothills ringing the Sacramento Valley in all directions, as well as some of the mountain areas. All of those places could see some record heat. And the places where I don't expect to see record heat are along the immediate coast, so we're probably not going to shatter any records in San Francisco or Santa Cruz or coastal parts of LA or San Diego, except possibly for overnight temperatures, which could be very warm, even record warm, even in those places. So it won't be hot per se, but there are many parts of the California coast actually this time of year where the record warm overnight temperatures are anything above about 65 degrees Fahrenheit. So we will likely see a lot of those records. Record overnight warms could occur anywhere in California. In fact, it's quite likely to occur for many consecutive days. Some places in the foothills in particular won't fall below 80 degrees at night for days. Some parts of the Central Valley may not really fall below 70 degrees for many days. A lot of places, in fact, I would argue almost the entire Central Valley will see at least one day above 110 degrees during this heat wave, and many places will see multiple days above 110, perhaps as many as 5 or 6 consecutive or at least cumulative days above 110, particularly at the far northern end of the valley and the far southern end of the valley, but perhaps also in some other places. So this heat wave is going to be most dangerous and most problematic, A, because of its long duration and extremely warm overnight temperatures, and B, because it will coincide with a pretty adverse fire weather setup, especially initially where there'll be quite gusty, potentially north to offshore winds, low humidity, and it coincides with the 4th of July holiday when there's going to be a whole hell of a lot of illegal fireworks being set off, and that could cause a number of ignitions. So quite a lot going on. This heat wave may well continue into next week. There's less certainty there, but it could. It will probably attenuate somewhat, but again, peak intensity lasting for 5 to 7 days and then only gradually weakening after that with a potential re-strengthening by mid-July. It's going to be rough. All right. I think I would encourage folks to check out my most recent blog post on Weather West, where I talk about this in detail. If anything, this heat wave is actually trending slightly more prolonged and more intense than I hinted in that post, although I talked about the range of possibilities. But overall, I think it mostly still stands. I will probably have another live session later this week at some TBD point, depending on how things evolve, perhaps fire-related or heat-related, depending on how things go. Be careful out there. This really isn't a good week to light off any fireworks. Not that it's necessarily ever a great time to light them off, given that in most parts of California you're not supposed to, but this is a particularly bad week to do so. Not like a usual 4th of July. Stay safe. By the way, extreme heat kills more people than any other type of weather hazard in the U.S. It's a greatly underrated killer. This is an event that will probably and unfortunately cause major health crises for some people and some deaths. That is the reality of major heat waves. We probably undercounted that morbidity and mortality historically, so part of it is that we're now more correctly realizing just how bad it can be for humans. But also, again, the reality is that we are seeing more frequent and more intense heat waves in a warming climate. Those are the facts. And that, we don't need to wait for a scientific study to come out in 6 or 12 months to say, okay, how much, did climate change make this heat wave more intense and more likely to occur than it would have been if we were still living in the early 20th century without this amount of global warming? The answer is yes, it did. I can't tell you exactly how much, but a pretty good start is by about the amount that California has warmed in summer times about 1.5 to 2 because of some of the feedbacks that exist during prolonged intense heat waves. So likely by at least several degrees. That's a pretty significant increment. And so keep an eye out. There are red flag warnings out for a good portion of interior Northern California. There will probably be some public safety power shutoffs by PG&E, really not in the Bay Area, mostly in rural parts of the western Sacramento Valley and the surrounding foothills, but potentially also elsewhere. And that, of course, doesn't mean there can't be dangerous wildfires in other settings. It just means that PG&E doesn't think that shutting off the lines would mitigate that risk very much in other places, because those ignitions would likely come by other means, but it will still be hot, dry, and breezy in those other places. So stay safe, stay cool, and try to avoid sparks this week because this is not a great time for unwanted fires. As much as we want to see more prescribed fire in the landscape, firework ignited fires during a prolonged and potentially historic heat wave is not the time to see that fire on the ground. I think that's something that's fairly easy to agree on. All right, folks. Thanks for your comments. As I mentioned in the beginning, there's a few links, a few suggestions for ways you can help support the channel. Right up at the top of the comments, you can scroll up and see those now and after the session ends. But otherwise, thanks for joining. Consider subscribing so that you'll get notifications when the next live stream is going to occur. Again, there probably will be another one later this week on relatively short notice. And stay cool out there. If you're on the beach, if you're lucky enough to live right on the ocean, you're probably going to be just fine. But if you're in the Central Valley or in the foothills or in the deserts of southeastern California, then genuinely be careful. This is not a typical July heat. This is definitely an anomalous and highly significant heat event for California that may last, frankly, a really long time. So with that, thank you, and I'll probably see many of you later this week.